housekeeping items. Due to the number of participants today, we've automatically muted your phones to eliminate interferences. Please enter any questions or comments into the chat box. If you have something to add to the conversation, please note it in the chat box and we'll call on you. If you do not have access to the chat box, you can email questions to professional@asce.org. That's professional@asce.org. Please turn your video off to avoid sharing your video with the group or being captured in the recording. We will be recording today. Please also close other applications, especially email, so that your system will run smoothly. And then lastly, please keep all conversations geared towards the benefit of the community and today's topic. We will begin today's roundtable with introductions from our panelists. Then each panelist will share their perspective and insights on the topic of overcoming disasters through relief and recovery efforts. So the panelists will also respond to questions from the audience. So again, please share your questions in the chat box. We love questions. So Tony, I'll go ahead and start off with you. Can you introduce yourself? Uh-oh, Tony, you're on mute.
I'm sorry. Tony Georges. I'm the president of the ASCE Lebanon section. I'm a professor of civil engineering. I mainly teach structures, and I am a civil engineer. I work for Pevida Highway Designers in Miami, Florida.
Awesome. Thank you so much for joining us. I know you said it's 10 o'clock where you are, so that's great that you're able to join us, even though it's the evening there. Next, I'll go ahead and turn to Kate. Kate, can you introduce yourself next?
Hi, I'm Kate Osborne. I live in Texas and I work for the Lower Neches Valley Authority. We are primarily a raw water supply company. And I was previously on the city council for my local city, and I got involved with disaster recovery through that.
Awesome. Well, thank you so much for joining us. Next, I'll go ahead and turn to Allison. Allison, can you introduce yourself next?
Hi, I'm Allison Perch. I'm based in Oregon and Southwest Washington. I'm a geotechnical engineer with Hart Krauser, which is a division of Haley and Aldrich. And I've been working on the resilience side for about 10 years, which started being involved with the ASCE Infrastructure Resilience Division and the Disaster Response and Recovery Committee. So I'm now co-chair of that, and I've been to several disasters with that group.
Awesome. We look forward to hearing from you today. Doug, can you go ahead and introduce yourself next?
Sure. Doug Taylor. I live in Fresno, California. I've been the Region 9, which is California ASCE Disaster Preparedness Chair for the last 5 years. We primarily focus on earthquake disasters in California, but lately it's been fires. We've responded to 3 fire aftermath of fires in the last couple of years.
Awesome. And Doug is joining us from Hawaii today, so it's 9 o'clock where he is.
I'm suffering in Hawaii.
This is so great to have a panel that's really global, talking about this really important topic. So I'll go ahead and start with our kickoff question. In what ways have you been involved in disaster relief and recovery efforts? What tips do you have for civil engineers who want to get involved in disaster relief and recovery efforts? So I'll go ahead and ask you, Tony, can you go ahead and explain kind of your expertise? Tony, you're on mute again.
Okay. Well, I lived most of my life in Lebanon, and as you know, it's a country where we faced a lot of trouble since the civil war up to recently, the big explosion that happened in the port of Beirut on August 4th, which was really something unexpected and something really devastating. Well, I mean, I was a young kid when the war broke out, and I had to be involved in disaster relief since I was a kid. By being involved in the civil society and by being, just helping out in different ways. And then I survived Hurricane Andrew in Miami in August 1992. and where we did a lot of work, just for reconstruction and assessment and rehabilitation. That was also another experience for me, where I had to work on disaster relief. And the most recent explosion in Beirut on August 4th, that was, the big thing that happened, and it was unexpected. The unfortunate thing about it is that it was not a natural disaster, it was man-made. And I think that, everyone acknowledged that it's like something really new as far as disaster management and as far as assessment. So basically, we did a lot of work in Beirut since August 5, the next day after the explosion, trying to help out, trying to reach to the people, trying to assess, trying to reconstruct, trying to make sure that people, they have a place to live and they don't have to leave their houses. And basically, so this is my experience in disaster relief. And most of the work I have done so far is kind of a volunteer work and kind of unofficial, especially in Lebanon, because we don't have preventive maintenance systems, and we were not prepared just to cope with a disaster like this.
Yeah, it's such a terrible tragedy. You almost don't want to prepare for something like that happening, right? But that's important, and that's why we're having this conversation, right? Kate, I'll turn to you next. What are your experiences with disaster relief and recovery efforts?
Well, I mean,
I was on city council when Harvey hit, and my area was hit really hard with that. And we woke up, I think it was a Wednesday morning, and they were out doing boat rescues. And I was like, these people need to eat. During Hurricane Ike, I lost everything. And while we were going through like all of our stuff out of our house and stacking it by the road, these people drove by and they were like, hey, do y'all want to eat? And of course we said yes, because there was a hot meal and we didn't have power or anything. And I took one bite of that meal and started bawling, because even more than a meal, it was hope. And these people were coming off the boat in Harvey, and they have nothing except literally the soaking wet clothes on their back. And hot meals make a big difference. So we started cooking for them. And then I got an email from the Texas section executive director later that day, and she asked how I was doing, and I just kind of lost it, because I was like, I'm okay, but everybody around me is suffering here. And because of that email, ASCE stepped up. We got donations. The ASC Houston chapter president went to all the different places around Houston that were turning away donations and started telling them, hey, Southeast Texas needs help. And from there, it just kind of, I guess the ASC Texas section saw the immediate people involved in the disaster, and we started taking steps to make differences at that point. So that's how I got involved. And the biggest tip that I have for people who want to get involved with disaster relief is get involved with the communities that you're naturally a part of. Not just your, location-based community, but like ASCE, we're a community, your neighborhoods, all of the different groups that you belong to. Get involved with them, and then you'll be able to help when the need arises.
Yeah, absolutely. Allison, I'll turn to you next. What's your experience with relief and recovery efforts?
So, as a geotechnical engineer living in the Northwest, I do a lot of work for my county and city clients when we have large storms, to go out and assess roads and come up with how we get things back open as quickly as possible, and then also long-term fixes. So that's one of the sides of it. The other piece, which is just in my normal job, and from a civil engineering standpoint, if you have whatever your specialty is, it's after disasters, cities and counties need help right away. So developing those relationships and making sure that you're there, calling in to those, using those relationships and calling and saying, hey, how can I help after disasters is one way to do it. The second note is like I said, I'm co-chair of the Disaster Response and Recovery Committee in the Infrastructure Resilience Division, and we go out to disasters of all sorts. I've been to 3 earthquakes, where we go do recons, study what worked, what didn't work, and how that actually affected community recovery. What stemmed from that is I've worked with the California Office of Emergency Management. They have a program called SAP, which is their safety assessment program. It's the red tag, yellow tag, green tag. Many states are kind of in line with California, but you can also do ACT 20 training and 45, which is that tagging ability. So it's a day-long class where you are certified to go and look at disaster, be a part of the disaster response. All cities and counties after a disaster have to, whoever's responsible for the buildings has to go and do tagging after a disaster to let people know what buildings and houses are safe. And that's actually one of the biggest pieces, because most of the buildings are, a lot of times it's minor fixes or things that they can do easily. Getting people back into buildings and back into shelter is important. So that's one of the things you can do. Check with your state emergency management board, find out how it is that they do that for your state. And you can either just get ACT 20 trained or look for a Cal OES training. It's their SAP program. They actually train it all over the country, and FEMA looks to the California list often when they are looking for disasters. That list has been called out to several of the recent disasters, the hurricanes in Puerto Rico and Texas over the last few years, and even down into the earthquake in Mexico. The other piece is, if you're interested in learning from the civil engineering side of it, the ASCE committee, our committee in the Infrastructure Resilience Division is looking to learn from disasters and how to actually change those outcomes with good engineering. So joining our division and being interested in the infrastructure resilience side is one way that you can also be involved. And then I'd also agree with Kate when she talks about being involved in your community. Most of my connections have been come by getting involved with the emergency management side, not just the public works side. That connection is really important after a disaster, because public works often isn't considered first responders, but if our roads and waters and electricity aren't working, then fire and police can't do their job. So we spend a lot of time in Oregon and Washington. We have a large 9.0 earthquake we're expecting at any minute. So in our preparedness side, we talk a lot about elevating public works and engineers to that first responder level, simply because everybody else can't do their jobs until we do ours. So, and public advocacy, talking to your representatives as a professional in the community is very respected. And I can talk about it later in some of the panels, but Oregon and Washington have done a lot to increase their resilience simply on the policy side, and it has been very much driven by ASCE and the engineering communities here.
Can I add to that? Don't just talk to your representatives, see what it takes to become one of the representatives.
Absolutely, that's great to get involved locally. There's so many opportunities. Doug, you're smiling, but you are also next.
Oh, great. Well, Allison was a good preview to what I'm going to say, because I live in California and we have a lot of earthquakes. Nothing major lately, but like Allison, we're expecting the big one someday. And when that happens, it's going to take an awful lot of engineers and people looking at buildings and doing rapid assessments. So yeah, we've had the safety assessment program, or the SAP program in California for a number of years, and really hasn't been used in earthquakes in, gosh, 10, 12 years. I think the last one was Loma Prieta, well, probably more than that. Anyway, but lately it's been fires. So I've been doing this for 5 years for California ASCE. So I have about 600 people that are trained in the ASCE database. And so when I get called from Cal OES, I look for volunteers with that database. And 2 years ago was the first one post-fire, which was the Paradise Fire. You've probably heard of that. It's actually called the campfire because it wasn't a campfire that started a fire. It was PG&E, but it was, anyway, that's how they name fires in California. It was so anyway, Paradise had about 18,000 structures that were burned down. It's a mountain community of about 27,000. So there was about 30 of us that spent a little over 2 weeks there doing rapid assessments. And just lately, last month, it was the Creek Fire well, really close to where I live in Fresno, up in the mountains, the communities of Shaver Lake and Huntington. There again, we didn't actually go through Cal OES on that one. I contacted Fresno County directly, said, hey, we've got these volunteers, they're free help to you to do rapid assessments. Unfortunately, they didn't even know about the program or how it worked, so it took them quite a while to spin up, to gear up into what it was. Anyway, we helped them for 4 days, doing about 1,800 assessments, and then after that, it was the Napa fire, and we had some volunteers go there. So anyway, as Allison pointed out, I think all disasters are really local. So it's the local building official that has to green, yellow, or red tag all these structures. So I guess the question would be is find out if your ASCE section or branch has a disaster response function, and if it is, get involved there. And also the state, what they have as far as disaster response. Are they going to need engineers to do rapid assessments? And right now, the SAP training is actually online through California, so it's actually free. Anybody can take the training. You won't necessarily be certified. You'd have to do that in a Zoom meeting, which we've done. But anyway, to get trained to do SAP work is a good idea. And then really, as Allison pointed out, find out what exists in your state, county, or city to enlist volunteer help.
Yeah, absolutely. Some great ideas there, Doug, as far as getting involved. So there's a few comments in the chat box so far, and I think the one really talks about terrorism and being prepared for that, as another risk in addition to natural disasters. So what are some of the things, I guess, that we can do to prepare for terrorism attacks in the future? Tony, can I maybe turn to you first for this one?
Yeah. Well, I mean, I guess this is the most unpredictable disaster that can ever happen, because you never know when it's going to happen, and you never know what is the scale of the damage that it will cause. It could be small scale, it could be a large scale thing. I live in a country where we face different scales of terrorism attacks until recently. I mean, I don't know if people know or not, but the mass of the explosion that happened on August 4, it can be compared, it's like 1/20 of the Hiroshima nuclear bomb that happened. That's how bad it was, and that's how destructive it was. It was it made destruction within a 3-mile radius where everything was completely devastated and completely destructed. So I guess, the only thing we can do, and I think that, like many legislators in the states are doing it, is just, to work on some type of research and studies. For example, what can you do to be able to defend these terrorist attacks as far as structural building? And I think that a lot of the defense buildings are being prepared for that. But I'm not sure, what can you do? I mean, are you going to fence every single building, every single structure? Because now it's like a worldwide dilemma all over the world. So I think that we should be more ready to cope with such attacks with different scales, and see exactly what can we do to be able to prevent them. On the other hand, although it's not engineering related, I think that we have to work a lot on the psychology of things like this and see exactly what could be done, just like to make these things not happen anymore. So this is what I can say about it. And we are suffering more than any other place in the world from attacks like this. And basically, engineers, and especially the young engineer, are witnessing such attacks. Okay, you should have seen the enthusiasm of the young engineers, of the students after the 4th of August explosion. especially that, the country is also facing major economical problem where the unemployment rate is so high. So engineers, they were all on the ground. They were calling left and right, ASCE Lebanon section, order of engineers. We want to help, we need to help. And they were on the ground. Okay, beside being a very bad experience, but at the same time, it was a good experience for these engineers to get their hands into helping and seeing exactly what happened. People from different societies, from different religions, they were all witnessing something that really devastated the country. So that made them think, what's happening around the world?
Yeah, absolutely. Those are some great ideas about ways to get involved. Allison, Kate, Doug, do you have anything to add?
When it comes to disaster response, anything, any terrorist attack, whether it be a bomb, or, you can have they can contaminate a water system, attack electrical systems. There are additional complications on the social side, but from an engineering side, you're just trying to respond to get systems back up and running. So it's all of the same things that you would do for a regular disaster. Building officials are responsible for inspecting buildings that are affected and getting them back up and running, and those pieces. So from the response standpoint, not necessarily the prevention, I think if you're ready for a natural disaster, you're going to be ready to respond to a terrorist disaster.
Yeah, absolutely. And then to follow up on that, there's a comment in the chat. It's not terrorism per se. We in the UK had a high risk of domestic terrorism from the 1970s onwards. Following Ron Point, 1968, we led the way in terms of robustness and tying of buildings, which U.S. codes really only started picking up on in the last 5 to 10 years. Simply tying of buildings to reduce the risk of progressive collapse would aid. Having designed buildings which withstood Hurricane Maria, which was a Category 5 hurricane in the Virgin Islands, we need to start considering what if in our design. So that's a great point that's being made. I also have another comment that's in addition to SAP training, if you're looking to become involved during the disaster, become a structures specialist is incredibly rewarding. So there's a link to that in the chat box. We've also got a few different organizations and charities that are being shared, and the question is if ASCE works with some of these charities. I know Allison and Kate, you're involved locally. Do your local sections partner with other organizations or charities?
Not specifically. Our local section after Harvey collected donations for local schools, but that was our chapter. Texas is a whole section. So, but we don't have a standing partnership in order to do disaster recovery.
I would say that we don't have anything that's officially organized. We do continuously work with AIA and SEAO in all of our policy pushes. So I'm assuming that would be a really simple collaboration if it needed to be after a disaster. We are working with, we're a fairly small state. The engineering community here is pretty small. So APWA, ASCE, SEAO, and AIA are all very involved in the same pieces on the resilience side. So we don't have anything official, but I know that we would be partnering with them in the event of a disaster.
Yeah, absolutely. I know AC does have many partnerships on a national societal type level. I'm not sure if any of these specifically are partners, but ASC does partner with quite a few different organizations. There's another comment: prevention is better than cure. Resilience is built in through good design and detailing, and then maintenance and inspection. So again, another good comment. Please, if you all have questions, please continue to share them in the chat box. I'll go ahead and turn to our next question. How are civil engineers uniquely equipped to aid in disaster relief and recovery? What knowledge, skills, and expertise do civil engineers bring to ailing communities? Doug, I'll go ahead and turn to you first. How are civil engineers uniquely equipped?
Yeah, like Tony pointed out, when disasters happen, the natural thing for engineers is how can we help? And that's the whole idea, is to get people and businesses back into their homes and businesses as soon as possible, because housing them and feeding them is very expensive for places, like FEMA and things. So yeah, engineers have a general knowledge of how buildings are put together, and from anything from residential to, skyscrapers. Certainly, things like skyscrapers and hospitals, schools like that, are going to be looked at by structural engineers primarily, and not just general civils. But even the civil engineers, like I say, they know how buildings are put together, and so they can help the building official do what he needs to do and decide what's safe to occupy and what isn't. And with that, I'm actually going to phone now and get off of the video. So.
Okay, sounds great. Well, we'll still be hearing from you later on. Tony, would you like to speak to how civil engineers are uniquely equipped to aid? Oh, you are on mute. There you go.
Yeah.
There you go.
Well, first, if I'm gonna talk from my Lebanese experience point of view, well, we don't have a lot. I mean, we learn from every disaster we encounter. Okay, so this is something new for us. But basically, engineering is multidisciplinary. So I think all engineers, they can play a key role when a disaster happens. For example, just geotechnical engineer, they have to go and inspect all the soil and the foundations. Transportation engineer, they have to secure circulation and make sure that all the hospitals and all the buildings are accessible for others. So basically, I do believe that engineering knowledge is very important when it comes not only structural engineering, it's all aspects of civil engineering. We're talking about environmental. The major problem we encountered after the explosion is water contamination. I mean, because it made so much pollution, so much gases that could be really poisonous. So basically, every single engineer has a key role to play. On the other hand, I mean, as civil engineers, we are known to be good managers. So on the other hand, you need some expertise in management to be able to take control of everything and put all these entities together. I also believe that as a civil engineer, we cannot forget about the humanitarian part of this. From my experience, in the explosion on August 4th, people, when there is a disaster, especially the people who are devastated, they need someone to talk to. They don't want only to talk the engineering language or structures or what's going to happen. They want someone to listen to them. So we were working as counselors. I, being a bridge engineer, I was also a former dean of students at the University of Balamant in Lebanon. And I think the best role I ever did, or the best bridge I ever did, is between people. So, we are multidisciplinary. We have the diversified knowledge, and we have to use everything we can, all the knowledge we can, when there is a disaster, to be able to help out and reach to the people.
Oh, I'm on mute. Absolutely, you make some great points. I'm going to go ahead and so another great comment in the chat box. Civil engineering is everything you see that's been built around us. It's about roads and railways, schools, offices, hospitals, water and power supply, and much more, the kinds of things we take for granted but would find life very hard to live without. And that's a quote from ICE, which is the civil engineering organization in the UK, if anyone's not familiar with that. Another comment, we can totally challenge the natural disasters, but we can reduce it up to a certain limit. So again, some great comments. Kate, you have your hand up.
I think it's really important for us to remember that the systems we design are designed for people. And when we're doing disaster recovery, our focus has to remain on the people. No matter what we're doing, whether we're trying to get people back in their buildings or trying to get them fed and housed, everything that we design goes back to communities and people. And we have kind of a unique role because Civil engineers are leaders, and we're trained to look at the facts as they are right now and consider what might be coming in the future and make decisions based on those factors. And that's extremely valuable during disaster recovery.
Yeah, absolutely. It's kind of, remembering the reason behind why we do what we do, right? Like those are some great points, Kate. So really, really great comments in the chat box. If you all have any questions, please feel free to share those there as well. So I'll turn to the next question. How can civil engineers influence design standards to better protect the built environment from future disasters? So Allison, I'll go ahead and turn to you first for this one. Allison, you're still on mute.
Yes, I was trying to get that off. So that was a little bit garbled. We're just on the next question, right? Sorry.
Yeah, I'm sorry. Did you not hear me?
Yeah, there it goes. Okay.
Audio today has not been fantastic. I apologize. I don't know what the deal is, but I'll go ahead and I'll read it again. I'm sorry, Allison.
I'm sorry.
No, you're fine. So, how can civil engineers influence design standards to better protect the built environment from future disasters? So, Allison, were you able to get that?
Yes, I did. It was the design standard part I didn't hear. I didn't know if it was the policy question or that one, so thank you. Design standards in general, out in Oregon and Washington, we have a tsunami hazard, and it's been really interesting to see how that's played out in the politics side. Design standards, as much as we would like them to be unpolitical, are very political. So we've had a lot of controversy adopting the new ASCE tsunami design standards here in Oregon. California, Washington, and Hawaii are also looking at the ASCE design standards and adopting them into their own states in different ways. But that being said, civil engineers, especially ASCE and others, do, we are putting forward the design codes. The question is, how do you get those adopted appropriately into your state system? And we do earthquakes. California, Doug can probably talk to this as well, but one of the things we're looking at is life safety code for earthquake, for everything, but the example is earthquakes. Does not guarantee you're going to be able to use the building afterwards. And one of the really big pieces in the resilient side and looking at long-term recovery is our understanding that if you can't get into the buildings because they need significant repair, that's not resilient. So Hurricane Sandy brought it up really well a few years ago when they showed that these LEED buildings they put a lot of money into to be environmentally sound did not make it through that hurricane and needed a lot of repairs, which is not necessarily environmentally sound and, again, not resilient if you can't get into the building after a disaster. So there are going to be discussions, especially on the West Coast, of how do we start to look at a step above life safety. So how do we look at office buildings and getting them into more of a school or hospital type level so that they're able to help our economy keep moving afterwards. That is a contentious discussion up and down the state, up and down the coast. And so really it's just back to being involved in the conversation, paying attention to what's going on, being involved in your community. We do a lot, ASCE Oregon does a lot of outreach to try to get people to understand what the seismic risk is. Being involved in policy councils, not only at the state level, but also the local level. Having an engineering perspective there is really important. Having them understand what a design code is. A lot of the bad press that's happened in Oregon over ASCE is just a complete misunderstanding of what the point of a code is. Developing a code does not say that we're going to developing a code on how to build things in the tsunami zone does not say that we recommend building things in a tsunami zone. It's just giving somebody the tools to do it appropriately if they're going to. So it all comes back to public education and getting people to understand what engineering is. The general public does not understand that, say, the Twin Towers on 9/11, from a civil engineering standpoint, the second tower, they did pretty well. They held up for a while before they collapsed, which if people were evacuating, a lot more could have gotten out. That's true in earthquakes as well. You know, our code design is really based on life safety, is getting people out of the building, not necessarily having the building standing. And that is a political decision because it's more expensive. Engineering's gotten better, materials have gotten better, and it is now really, especially from an earthquake standpoint, but from other disasters as well, it's not as expensive to build those buildings to be able to withstand the disasters that we anticipate. The engineering is there. So educating people that you can actually do it and that it's important is something. And it's looking at the costs. I'm working with a couple private clients right now and explaining that it's generally 1 to 1.5% to get your building from life safety to immediate occupancy after our design level earthquakes of the building cost, in addition to your building cost, but it saves you 20 to 40% of that original construction cost to try to fix it afterwards. So if you have a building owner that actually is trying to keep their building or their piece of infrastructure usable after an earthquake, it does make monetary sense. FEMA's been doing a lot of work and studies talking about the fact that every dollar you spend before mitigation, you save in mitigation before disaster saves you $6 afterwards. Being aware of what those facts are and educating the public, our owners, and our city councilors and mayors and legislatures is important so they understand what those codes do. We do a good job of developing codes and following codes as we sit in our cubicles designing things. But I think more and more when we look at our infrastructure, being advocates and helping our cities and counties and states advocate for better spending on infrastructure is important. You know, one of the good examples in Oregon and Washington is leased pavements. We have very few snow events in most of the western portion of the populated states, and when they do happen, it's a total mess. But people will get studded tires for the entire summer, and our pavements don't stand up to them because we just don't have the money up front to design it to do so. So we repave our roads all the time, and a lot of the wear is studded tires. If we were able to engineer them at first and spend a little bit more money up front, we wouldn't have to be interrupting I-5 freeway traffic doing those repairs. So bringing the monetary costs into it and explaining a life cycle cost of all of our funding is on a 2 to 4 year budget cycle. We need to help start to expand that, is looking at spending more money up front is saving you money in the long run, and changing that conversation so that everybody's not focused on our infrastructure in a 2 to 4 year budget cycle. There are things that should be maintained because that's the way it is, but there are also a lot where if we're doing little teeny maintenance every 2 or 5 years, replacement's probably the cheaper option. So looking at those, looking at a bigger scale and trying to provide that information to our clients and the owners of our infrastructure so that they can make that case and end up being more disaster resilient. And I think it's going to come up a lot, especially on the West Coast, because everybody's trying to get mandatory retrofits and other types of seismic design into the code. So we're looking at a higher design level. And the building owners and the real estate agents are a big lobbyist to get passed. So us as professionals really need to be out there coming up with intelligent ways to help people understand the problem so that we can get those higher design standards for the disasters that we are all expecting.
Yeah, absolutely. Those are some very practical examples. Allison, thank you for sharing all of those. There's another comment in the chat box. Sounds as if life cycle analysis would help up front to help understand the risk and costs. Perhaps this should be a code requirement. Otherwise, the lowest cost initial build may be the selected without understanding repercussions. So again, Allison, you're shaking your head. That's great points. And then we've got some information about ASCE's Grand Challenge in the chat box. But Kate, I also want to give you an opportunity to answer this question as well. What are opportunities that you see for civil engineers in getting involved with the with design standards?
One of the things that we've done locally is actually getting out and figuring out how to get the information to the people who can make the changes, like Allison just said. We have a regional flood coordination study group that was formed by our local chapter's section director. She's the head of civil engineering at Lamar University. And she has gotten together various people from Lamar, people from the University of Texas, people from local cities, drainage districts, city floodplain managers, county floodplain managers, river authorities, the Texas Department of Transportation, the Texas Department of Emergency Management, the Department of Public Safety, the USGS, NOAA, and the United States Army Corps of Engineers. And what this is doing is fostering conversations between the local people who see the actual flooding on the ground and the people who are doing the research and the studies and the policy making to mitigate that flooding and the effects of that flooding. And it has been a wonderful resource so far. And she took the initiative to actually step up and be a leader and foster the lines of communication that we needed in order to make a difference with the information that we have locally. And the group is intended to be a model for future expansion throughout the state and hopefully beyond the state in areas that flood. So I guess actually getting out there and talking to people is the biggest thing that we can do to influence the design standards.
Absolutely. I know you've talked a lot today about leadership and the importance of being a leader as a civil engineer, and that's a great point.
And building communities.
And building communities, yes.
Communities foster information exchange, and that's what gets stakeholder buy-in to actually make changes.
Absolutely, that's so key. So I'm going to backtrack within the chat box because I missed a few. Here's a comment, not a question. Thanks to ASE for Climate Resilient Infrastructure Manual of Practice. This MOP lists all of the ASE standards that are affected by changing climate factors. So that's great. Then we've also got a comment about Eurocode 8 and the NZ codes have a two-tier approach to seismic design. 1, ULS life safety, and 2, SLS continuous operation. You've also got a comment, we can use disaster as an opportunity. The best engineer is to change disaster into an opportunity. Yes, of course we can. So the question then being asked is, what is the benefit of an earthquake in the sense of civil engineering? So I don't know, thinking about, earthquakes and how they've, I guess, developed design and how we prepare for them in the future is maybe that's the question. Allison, you're kind of thinking through that one. Do you have any about that as far as opportunities within designing for earthquakes?
Yes. Part of why we struggle here with earthquake design standards is that, especially in the Northwest, we don't have them that often. California has them enough that people remember they exist, but up here we really don't. And so, unfortunately, the benefit of a nice 6.0 in a slightly less populated area than the Portland metro area would probably do us a lot of good on the policy standpoint, because we could actually remind people that they happen. But I do think that there's the learning side from it. So if we're actually benefiting from the earthquakes happening, that's kind of where we come in at Infrastructure Resilience Division, is going and studying what worked, what didn't work, and how that affected the community recovery. We spend a lot of time looking at emergency response when we're unprepared for disasters, where the real question is the recovery side. So response is getting everybody fed, watered, and sheltered, right? We were more worried about infrastructure back up and running and our communities functioning from an economic level. So looking at how to talk about getting that infrastructure running, I think, is important. And that's where we learn from all disasters, not just earthquakes. We've been to hurricanes, all of those pieces. Every single disaster, even if it's a small flood in your community, has lessons learned that we can apply other places. The other thing that we can use from them is the design parameters. So climate change is a big one in that everything's changing fairly frequently, and we're not always sure what the next big 500-year storm is going to be. So the more data we get, the better. Earthquakes in general, we're doing the best we can on the planning for those types of earthquakes, but looking at what engineering worked and didn't and lessons learned is probably the best benefit of an earthquake.
Yeah, absolutely. We've got to learn from past experiences. There's a comment about Cascadish. If that shakes, we'll all know about it. It's, excellent points as far as trying to take what's happened and move forward in the recovery efforts. So I'll go ahead and go to our next question. Have you been involved in influencing or advocating for disaster mitigation legislation or policies? And I know, Allison, you've talked about this pretty specifically about, what successes you've seen, but would you like to elaborate a little bit more on some of your efforts?
Yeah, I can. So Oregon, well, actually, I can't remember which one came first, but San Francisco has a SPUR, which is a city resilience plan looking at seismic resiliency specifically. Both Oregon and Washington looked at those and said, hey, that would be a great idea. We should do that for our state. So the Washington legislature said, we want one. Here's money. Go do one. It's a great plan. It's called Resilient Washington. They looked at a Cascadia subduction zone evaluation and kind of looked at, okay, what are we looking at? How toast are we? Oregon did the same. The Oregon legislature did the same thing, but they said, we're not going to give you any money, figure out how to do it. And Kent U with Infrastructure Resilience Division and ASCE got 170 volunteer engineers together from all walks of engineering, and they wrote a 300-page assessment and plan for Oregon. They're equally good plans. The difference is that the Oregon one lives. Everybody knows about it. It's believable because ODOT and everybody were involved in it, and everybody knows about it, and they went back home and talked about it. If you talk about resilience in Oregon or Washington who have a very similar risk, everybody knows that plan exists. We have a state resilience officer, and we're starting to push policy through. That was all engineers and architects pushing it through, going and talking to the state seismic policy committee and making sure that it was approved, talking to the policy advisors and pushing it forward, and then volunteering to write the plan. I am not saying we should be doing resilience plans for free. That is not my example. But it is a good example for how having engineers involved in the process makes it significantly more believable, and something that people take to heart and really understand and believe that it's going to happen. We are not the only people that have an earthquake risk. There's a pretty large earthquake risk all through the St. Louis and the New Madrid fault area in the middle of the country. And I've actually talked to people at Missouri they've called and said, how did you get a statewide resilience plan? And I said, well, let's talk to your engineers in your ASC section and see who can get it started. It's all back to being involved in your communities and understanding what has to happen and talking and educating as we go forward. So the only reason we have seismic policy in Oregon is because engineers advocated for it and pushed it. So.
Yeah, so I'm hearing a lot about that as far as really getting involved, stepping up, being part of your community, advocating. Those are all great things. There's a comment in the chat box. The ASC Grand Challenge is a commitment to rethinking what's possible in our industry. So that kind of leads us to our next question. How can civil engineers innovate to design more resilient infrastructure that can better recover from future disasters? So Tony, I'll go ahead and turn to you first.
Yes, well, I think my first answer for that would be research, and not any type of research. It has to be applied research. It has to be in collaboration with academia, with the industry, with the consultants, with contractors, with everyone. And I think there is a lot of innovation being done nowadays when it comes to materials. But then this material, it has to be used from a structural point of view and consider and do some research on all aspects. The other thing I can think about is, maybe to just to be able to define for different type of disasters, natural disasters, different natural disasters, other type of disasters, what are the consequences? Just to be able to know what's the impact of all these disasters. And the third thing I can think about is basically not, just what type of prevention measures we can take. This is another important point that can help a lot when we work on prevention measures to be able to get some of the things being done in an innovative way. But I think research is very important in this aspect, and it can really help a lot, and it can really make structures more resilient and less susceptible to damage.
So, oops. Yeah, absolutely. Kate, I'll turn to you next.
I don't know if you've noticed or not, but I'm not that big on the technical design side of advocacy. There are a lot of engineers that do that. I also think, though, that we need to do the research, but the research in the universities and everything is important, but we also have to get out in our communities and make sure that we aren't solving problems that don't exist, and make sure that we are solving the problems that do exist. One of the things that just has stuck in my mind, during Harvey, there was one road open between Beaumont and Houston. It's about an hour and a half drive. And this was the main road. This was the only way to get into Beaumont entirely. And this was the road that people were bringing disaster relief stuff in on. And the whole road was clear, except for in this probably 40-mile stretch, there was a half a mile that had water over the road. And when the water went down, there was one lane open there. And because of this, traffic backed up for like 14 hours on each side of this little blockage, because they had to, you know, this side goes, and then they stop traffic and this side goes. And that caused such a backlog on getting so many supplies into our area when people like needed food and everything. Because when somebody designed this road, they took this half-mile stretch and made it just a little bit lower than the entire rest of the road. And that's not something, I mean, we don't go and research roads that way in universities and stuff, but when you're on the ground in the community, that was a serious problem. So once again, I say, get involved, get to know what's actually happening, and make the difference that needs made.
Yeah, absolutely. Allison, I'll go ahead and turn to you next. How can civil engineers innovate to design more resilient infrastructure?
I'm gonna piggyback on what Kate said in every way. One of the things that's been really interesting in the resilience side, especially on ASCE side, is, and I love all of the work that's coming out of the universities and studying the resilience side of it. We haven't really come back and said, okay, but this is what we need to do on a practical level. Having lessons learned and understanding what happens in actual disasters, how it is related to infrastructure and what works and what doesn't work is so important. So if you're influencing and advocating things, the best thing is to have examples from existing earthquakes or floods and how it worked and how it didn't work, and pushing forward. So everybody's going to have a disaster in their community. Well, it's 2020. If you haven't had one already, you'll probably have one soon. And if not, in the near future. So look to those lessons and try to figure out how to go from there. Without having examples, people kind of, or an immediate problem, it's really easy for people to say, yeah, that'll happen down the road. I'm more worried about my 2-year budget cycle or something else. But if the more that we can do to use people's understanding of what has happened, whether it be in another country or in a town over, or even better in their own area, the more that we can use that for advocating. So the studies and research that is involved around those existing examples is the easiest for us to use for advocating. All of the research is important. I'm not saying that any of it is not important or great. I love reading those papers, but when it comes to actually influencing people, having actual lessons learned and practical solutions that look at infrastructure on a level, really providing opportunities for people to do, kind of low-hanging fruit that they can do to be more resilient as quickly as possible, is really the easiest things to sell and the easiest things to get people to buy into.
Yeah, absolutely. Kate, you have your hand up.
Bouncing off what Allison said, making a practical difference can be done in a really powerful way on a local basis. I think our Southeast Texas chapter has about 12 active members. And out of that, we've led the way on putting together a study on how the Texas state policy can best handle flood mitigation. And that led to the creation of statewide region groups that are based off watersheds instead of off like Houston fixing things and then still flooding when the upstream floods. And we have put together this flood coordination study group that's proving to be a really powerful thing. A small group working to make a difference locally can end up making a huge difference.
I'm on mute. No, those are some great points. And I think the comment in the chat box kind of reflects a little bit of what both Allison and Kate have said as well. Civil and structural engineers are often the bottom of the pile on any engineering project, but we are often the last to receive information, first to deliver on projects. In the UK, for sure, other engineering disciplines, and certainly architects and project engineers, project managers, are given higher credibility or greater notice is taken of what they say. We need to lobby society better and raise our profile so people listen to what we have to say. So I think, you know, leadership, like Kate, you said over and over and over again, is so important.
I think also part of that is communication, because even if people in general don't listen to what we have to say, if we can make connections with the people who do get listened to, we can still make a difference. We
Absolutely.
have to build relationships outside of just other engineers.
Absolutely. So I think, you know, we're getting a little bit close on time. I think we can probably go ahead and share some closing thoughts. I know Doug never was able to rejoin us. I'm sure he is on a Hawaii beach right now, enjoying himself. It was nice of him to be able to join us for, even while he was on vacation. But I'll go ahead and ask you all to share maybe, you know, 30 seconds to a minute of your closing thoughts about this conversation. Tony, I'll go ahead and turn to you first. You're on mute, Tony.
Okay, thank you. Well, I think this was a great conversation. This was a great roundtable, and I think the most important thing that we need to speak out, tell our stories and share our experience, and this is very important, you know, for people to learn from. Beside the cause and beside the standards and the decision by the legislators, but I think sharing our stories is very important. And like it was mentioned many times, we need to get engaged. We need to get engaged in our small community, local community, in our neighborhood, on a nation level and on a global level. So if we all work together, you know, sharing our experience from multi-nations, and this is what happened in Beirut in Lebanon. We had so much help and so much dedication from outside, and this is what making the recovery of the explosion being faster and being healthier. Thank you.
Absolutely. Kate, go ahead and ask you to share your closing thoughts.
I am going to share the Texas section vision statement with y'all. Texas civil engineers are leaders in their communities, building a better quality of life across the street and around the world. And I was involved in helping write that, and it has really shaped my life, because no matter what we do, whether it's work or outside of work, I'm working to build communities. I get involved with my community and try to build this, because that's how we make life better. And as civil engineers, that's our job, is making lives better. We build society. So, show up, get involved with your local people, get to know people, and make a difference.
Absolutely. That's really inspiring, Kate. Allison, I'll let you close us out.
Not sure I can top that. I just echo it on most accounts, is getting out there and getting involved is the most important thing. Knowing that as an engineer, you have valuable information and people are going to understand that you are an expert in your field, and you can provide practical solutions is really important. And one of those groups, if you want advocacy right away, those people that are listened to, is the emergency management side. Not only do they have control over FEMA money, but they often have the ear of policy advisors as well, and can get you kind of help develop those relationships. So that would be a great place to start, is reaching out to your local emergency management, and you're getting the public works side involved in the emergency management side is very helpful.
absolutely. This has been a really great conversation, and I'll go ahead and share the link to where the recordings will be made available, and also I will share in the chat box a link for where you can register for other free ASCE events. But I want to thank all of our panelists for some great insights. I do want to remind ASC members that you can continue this conversation on ASC Collaborate. And for anyone that's not a member, please feel free to contact me about the benefits and resources that ASC provides. I know we've shared a few of them in the chat box so far today, but thank you again. This has been a great conversation. I can't thank our panelists enough. Tony joining us, at 10 o'clock at night from around the world. It's fabulous to be able to connect with you. And Allison and Kate, thank you both for sharing your insights as well. This has been a great conversation.